Now this is part 3 of my series on squares, rectangles, and variables. Now then, why do they say that the area of a triangle is 1/2 the base times the height? Okay, I'm now going to answer that question. What is the area of a rectangle? Well, it's base times the height. Okay? Now what they did was they divided this rectangle into 2 evenly sized triangles. These are triangles, both of these. If you look at them carefully enough, you'll see that this is one triangle. Let me put this down here. This is triangle number 1. This is triangle number 2. Now, if the rectangle has an area of base times the height, and you divide this rectangle into 2 triangles, what are you going to have? The triangle is going to be 1/2 the base times the height. That's where they get that from. Now, where did they get triangles from in the first place? Circles. That's right. They got triangles from circles. What they did was they drew true radii of a circle, and then they drew this line that connected the 2 radii of a circle. And that's where they got the triangles from. How do you think they draw triangles? They draw a circle first, and then they make the connections. That's how. Now, the thing is that circles have ratios. What is a ratio? It is nothing more than a fraction. And what's a fraction? It's a division problem. It's a division problem in which the numerator is divided by the denominator. That's what it is. That's what that line is there for. It says you're going to divide the top number by the bottom number. That's it. Okay? Now then, a triangle is composed of ratios. B over A, C over A, and B over C. Now the thing is, you don't want to use big-time fractions inside of mathematical equations. Why not? Because it gets messy, that's why. You have a lot of notation you don't have to have. So what did they do? In the line of triangles like this, where you've got these kind of ratios, okay? When you got triangles like this, and you got ratios like that, we don't want to write them down as fractions. Instead, we want to disguise the fractions. And that's what they've done. That's why they say sine, cosine, and tangent. Now, we already know that sine is some kind of a line. I showed that in a previous video. We also know that tangent is some kind of a line because I showed it in a video. I said the tangent is a line that touches a circle at exactly 1 point. I taught that in a previous video. Now, what about cosine? It is a complementary sign. That's what it means. It's a complementary sign. So, it's a line that is a complement to that line. And that's where they get it from. So, instead of showing you this fraction, they're going to show you this. Instead of showing you this fraction, they're going to show you this. And instead of showing you this fraction, they're going to show you that. And that's all there is. All they've done with sine, cosine, and tangent is they've disguised fractions with those words. It's the same thing. It just makes the writing a little less messy and a little more comprehensive. That's all it is. And that's the way it is with secant, cosecant, and cotangent. Same concept. They've just disguised a whole bunch of fractions with disguises. That's all they've done. Alright, now that you know all this, hopefully the rest of my videos will make sense, and finally you can get things understood. Alright, I will tell you more in a future video. Stay tuned.